So a particle p moves along the x-axis so that at time t seconds, where time is always positive, the velocity of p given by v meters per second is 5 cos 2t. So that's an expression for speed or velocity. Find the value of t when p first comes to instantaneous rest. So instantaneous rest just means when the speed is 0. So in other words, let v equals 0. That's it. Okay, so that's basically means you're not moving anymore. Now to do that, just equate this to 0. So we're going to therefore have 5 cos 2t equals 0. And just solve it. Divide 5 across, you still got cos 2t equals 0. My personal advice is to keep your calculator again in radian modes, yeah? And now cos inverse this and then divide it by 2, you should have a result of t equals pi over 4 in your calculator. And then that's basically roughly 0.785 seconds. So that's it. So it basically goes instantaneous rest in less than a second. That's how quick this particle is. Now for part B, find the magnitude of the maximum acceleration of p. Now first things first, let's get to acceleration. How do you go from velocity to acceleration? Well, all you got to do is differentiate. There's like a certain rule here. When you always start displacement first. Let's call it s. S goes to v and then goes to a. This is the order of the differentiation. So if you had the displacement equation, differentiate to get v. To get to a, differentiate again. So we can say, alright, to get a, differentiate this equation. Focus on the cos 2t. Yeah? So let's ignore the 5. So leave 5 for a second. Cos 2t basically becomes a minus sine 2t. So let's put this in bracket, minus sine 2t. And then you got a 2 inside. So you differentiate that so you get 2 outside. So it'd be times 2. In other words, you're just going to get 5 times 2, which is 10. It's going to end up becoming minus 10 sine 2t. That's really it. Okay? So now we've got this value. It says find the magnitude of the maximum acceleration of the particle. So the maximum possible way. So you want the biggest possible value of this expression you can get here. And to get the maximum possible value, we just have to ask ourselves, what is the maximum value sine 2t can take? Now, if you think about it, guys, it's a sine wave, right? So if it's just moving like here and it's floating between -1 and 1, the maximum possible value of sine 2t would be 1. So in other words, the maximum value would be minus 10 times 1. So we could say that the magnitude of the maximum acceleration, so we do this kind of magnitude sign, is just going to be, and when you do magnitude, it's always positive, it'll be 10 meters per second squared. That's all it is, guys. When you get sine or cos and they want to find the magnitude or the maximum value of this, it maxes out 1 for both of them. If it's minimum, it'll be -1. So you times by -1. And that's it. Now for the next bit, it says when the time is 0, p is at the point A, where the distance OA is 0.2 meters. When p first comes to instantaneous rest, p is at the point B. Find the distance of OB. So what I'll do here, guys, is firstly, because we're talking about distance, we need to firstly get an expression for distance, or in this case, displacement. We already got v, so how do you go from v now to s? Well, if you went downwards, which is differentiation, to go back up, you integrate. So we're going to go ahead and integrate that equation, yeah? So let's just rewrite everything here. So part C, we know that the velocity was 5 cos 2t, okay? Now to integrate this, we're going to call it S. To integrate 5 cos t, just like how you differentiate, instead of, when you differentiate, cos becomes minus sign. When you integrate, it becomes plus sign. And as for the 2, when you integrate, it goes underneath. So let's have a look. When you integrate this expression, you're now going to get, let's leave the 5 as is, 5 sine 2t, and you're going to divide it by 2. And then we just write plus c. Now going back here, what's it telling us? It's saying that when t is 0, the distance is 0.2 meters. So let's go ahead and plug that in. So these are your initial coordinates. So we could say, okay, when t is 0, therefore the expression s, our distance we're going to use for now, is 0.2. Therefore, let's put this in. You're going to have 5 sine, remember just use your calculator for everything, yeah? Over 2 plus c must equal 0.2. Let's work this out. So sine 0 is basically 0. So in other words, all of that is 0. So therefore, c must be 0.2. Okay, that's cool, nice and easy. So now let's go ahead and update this equation. So we now have, okay, so the displacement equation is 5 sine 2t over 2 plus 0.2. Now back to the question, it tells us earlier that, so we've done this part, the first line, so always break into bits. It says when p first comes to instantaneous rest, so this is actually referring to part A, that's when instantaneous rest. And remember when that happened at t equals pi over 4, so let's make that note there. This is talking about when t equals pi over 4. And then that's how we know b is p is at the point B. It wants us to find the distance of OB. Okay, cool. So all it really wants you to do is just plug in pi over 4 for t. And I think that's really it. So okay, so we say therefore for distance OB, when t equals pi over 4, just plug it in. The distance is now going to be, and then again, just plug it all in and then put in your calculator. 2 times pi over 4 over 2 plus 0.2. And I did this already, guys, and I think you should get roughly 2.7 meters. And that's it. This should cover it all.